Hello guys, welcome. And this is our video for experiment 7. Now things are a little discombobulated. I've got things all over the place, but we are going to be talking about experiment 7. So when we talk about experiment 7, a couple things we want to look at. So this is the summary for experiment 7. I've got a couple of those open, so I think I'm going to try and close a couple of things. This is the experiment 6, so I'm going to close that because we don't need that. This is the data sheet that comes with experiment 7. This is the summary for experiment 7. This is the post lab for experiment 7. And this is the activity series for experiment 7. Now, in addition to that, you'll also see the simulation for the voltaic cells that goes with this. So I'll open this also. These are the two things that you've been referred to for these. Now, there's a reason that you have these two simulations. Now, they are meant to be able to give you the data that you would see here. So you'll see that there's a reaction with the zinc metal, and it will tell you whether these reactions happen or not. These two simulations will show you whether those reactions happen, but you can also see here that it will tell you what those reactions look like. So it's up to you whether you look at this data sheet to tell you whether those reactions happen, or whether you actually look at whether those reactions happen in terms of what those reactions look like. So that's entirely up to you whether you do them in terms of the simulations or not. I prefer to look at them in terms of the simulations because I want to see what they look like. So for me, it's easier to look at them in terms of what do they actually look like in terms of, what is actually happening with the data. So for me, that's a better way to handle it. So when I take a look at this, I want to see what does it actually look like. So I come in here and I say, okay, they've asked me to look at the reaction between zinc and hydrochloric acid, right? So H2SO4. So when I come into this simulation, I can see that here I have zinc, and over here I can see, all right, zinc and hydrogen here. This is one of those reactions that I can look at, zinc and hydrogen here. So that's zinc and hydrogen, and that's one of those two reactions that I'm looking at. Now, I can also look at zinc and copper. That's this one, okay? And so this would tell me about the zinc and copper. This would talk to me about zinc and sodium. Zinc and sodium I don't see here. Zinc and silver is here. So this would tell me about zinc and silver. And I can also change this to copper. And then I can look at copper with hydrogen. Can see what happens when I do that. Okay, so I can make those changes and see what happens. Okay? Now, a couple of the things that you'll note when you do this. Okay, so if I have zinc here, and I have zinc, and I see zinc, and zinc comes out to Zn2 plus, and H2 here, right? So I'm getting the Zn going to Zn2 plus and H2 coming here. So H2 coming out and this working in this direction. So I have zinc going out to give you Zn2 plus, and I have this reaction coming this way, then that's actually going to work in this direction. So I'm now getting the this energy coming from the zinc to, so zinc is being taken from zinc solid to produce Zn2 plus. So the electrons are coming out of this, leaving here. So the electrons are coming out and then coming over here to react to give me the H plus out. Okay, so I am producing the H plus to brain is not working. So when we look at that, what I'm seeing is that reaction with the zinc metal and the sulfuric acid, I am seeing that reaction. So that's what I see, is that I get those gas bubbles. And that's exactly what I'm seeing. So I am predicting that that will work. That is what I actually see. Okay, so that's what I'm actually seeing in that reaction. Okay, so that's what I'm seeing, is that I'm actually taking the zinc, I get that reduction. So I actually move those electrons from the zinc to the into the wire, and then they come over here, so that I then get that H plus produced, so that I can make this happen. Okay, so that actually happens. Now, when I look at the copper, on the other hand, and I have this copper, I am now taking the copper 2 plus, and I'm taking the copper 2 plus from solution and depositing copper at this electrode. Okay, so copper's coming from solution and depositing. So now we're going the other direction. Okay, so that reaction is not happening the same way. So it's not happening the same way. And that's why the data you'll see here is that I don't have copper reacting the same way. And so copper working with that, the sulfuric acid, there is no reaction there. And that's because it's happening in the opposite direction. Okay, so that's what we're talking about when we talk. Okay, so those are the things that you're looking for, is it happening in the right direction or not? Okay, so that's what we're talking about there. Okay, so that's what you're looking for, is which direction is that reaction actually happening? Are you actually seeing that the metal is reacting and it's going from the metal state to the ion state, or from the ion state to the metal state? Okay, so that's what you're looking for. Is it happening from the metal state to the ion state, or from the ion state to the metal state? So that's what you're looking for. Okay, but if it's going from the metal state to the ion state, then that's what you're looking for. If it's going from the ion state to the metal state, that is not the correct direction. So that's what you're looking for. Now, not all of them are going to be happening in this phase. Okay, so you won't see all of them here. So some of them you won't see here, and that's when you have to look at this activity series as opposed to the other one. And so there was one that we didn't find here, and that was the reaction between the zinc and the sodium. Notice that you didn't see the sodium here. And so that's when you would have to come in here and look for the zinc here and the sodium over here. So here we would need zinc and sodium, and then you would need to run this to see if this would actually give you a reaction between those two. And so you need to see, can you get the zinc to be replaced by that sodium? And what you'll see here is that you don't actually see that. Okay, so that's why you see that this data does not indicate that you are getting zinc reacting with that sodium. There is no reaction. Okay, so that's what you're looking for, is to see if that data actually happens. And if you're confused by any of what you're looking at, you can always check this data to see, okay, does it make sense? Does it correlate with what I think I'm seeing? Does it, am I getting what I think I'm getting? Okay. Now, the other thing is that when you're looking at that titration, okay, when it's asking about the volume of the diluted sample, it'll ask you, what is the volume, volume of the K-4 that's been added. That will ask you. So, what is the volume that you've added? That's the difference between these two volumes. Okay, so that's what you're looking at there. Initial minus final was that volume of the K-4 that's added. The volume of the diluted sample is this is the mass of the sample, so the volume of the diluted sample. And then the mass percent of the H2O2 in the sample you'll be able to do, and the mass percent of the H2O2 in the bottle based on. Okay, so you should be able to calculate those as well. All right, so you should be able to get that from the data you've been provided here. Okay, you should be able to balance the redox reaction that's here, and so everything that you should need should come from there. All right. I apologize. So you should have everything you need based on the information that you've been given here, based on the information that is in these guys right here. Okay, so you should be able to use those two simulations to get the information that you need, and between those and then what's provided here. Okay, so questions, comments, problems on any of that? Hope not. But if you have any questions, then please let me know. And I don't think that you actually need the percent of H2O2 on the bottle. Actually, you should be able to find this on any bottle of hydrogen peroxide that's around. If you can't find that, you should be able to Google a bottle of hydrogen peroxide just to look at what is the actual percentage on the bottle and then calculate the percent error based on that. So, and then you should be able to talk about what are, are your results accurate? So are the number that you calculated, is it accurate based on how different your results are from what is here? Okay. So if you have any questions, please let me know. I think you should be good with that, but if you're not, please let me know. Okay. So questions, comments, problems on any of that, please let me know. I think you should be good. But all the data that you should need should come from the information that's in this data table, and being able to look at what is in these guys right here. And then your post-lab information, this should be based on, so it's a stretch from what information you've been provided in the lab. So it's a little bit beyond what you did in the laboratory, or what information was provided to you in this lab, and something based on that. Okay. So you should be good there. If you have any questions, please let me know. I'll be happy to help. Okay. All right. I will talk to you guys soon. Thanks.